Greetings to all my tech heads out there in the KevTechify nation. And if you're new here, welcome. In this episode, we're going to look at Introduction to Wireless. We'll be discussing the benefits of wireless, the types of wireless networks, wireless technology, 802.11 standards, and then finally looking at radio frequencies. This episode is part of my series on switching, routing, and wireless essentials for the Cisco Certified Networking Associate, also known as the CCNA. I'm Kevin here at KevTechify. Let's get this adventure started. Wireless technologies are part of your business nowadays, part of life. We see them in our homes, we see them in business, we see them in all the spots we go to, this wireless technologies. What this is the type of network. It allows communications to happen. It allows you to get the information you need. Wireless LAN give us mobility. They allow us to do what we want, where we want, when we want. Traditionally, in a wired network, you had to be wired into the network. A lot of times this is symbolized by a cubicle with a computer plugged into the wall, not very mobile. But in today's world, you can take your device, whether it's a laptop, a tablet, your smartphone. You can take that from your office into the conference room, into somebody else's office, and you can have your devices. You can go wherever you need to. You can go to the coffee shop. You can connect in wirelessly there. This is the functionality. This is the big benefit of wireless. It allows us to change to the situations as needed. Now, there are kind of four main areas of wireless, and a lot of it comes down to the area it covers. We have the WPAN, the WLAN, the WMAN, and the WWAN. So, the wireless personal area network. This is typically a low power, short range. We're talking 10, 20 feet, maybe up to 30 feet on a good day. This is a very small network. Typically, it's personal. It's just for you. It connects you to devices that help you do your job or make your life more comfortable. The one big example of this is Bluetooth technologies. We have Bluetooth on most of our mobile devices nowadays, laptops, tablets, smartphones. And then we use Bluetooth to connect into them different ways. We have Bluetooth headsets or earbuds in today's world. We look at having a wireless keyboard. That a lot of time is through Bluetooth. We have our cell phones that connect into our vehicles, and we use Bluetooth to do that. Once again, short range, typically it's personal. It's your personal network. Nobody else uses that network. Then we have the wireless LAN. This is a medium-sized network. It's supposed to be up to about 300 feet. Sometimes it's less, sometimes it's more, depending upon environmental walls, interference, that type of stuff. But this is based on the 802.1 standards from IEEE. They fall into two areas of frequency, typically 2.4 gigahertz and 5 gigahertz. This is what we see when we talk about wireless. The end users, this is the wireless they use. This is where your laptops, your tablets, your smartphones, they use this to connect into a network. It typically, there's some device on there that provides the bridge from the end devices into your corporate network. Next type of network is a little bit bigger. It's a larger geographical region, such as a city or maybe a district. And what this does is it's for companies to provide wireless, or cities to provide wireless throughout there. The end user a lot of times doesn't necessarily connect into it. It's usually for more of the corporate backbones. And finally, we have the wireless WAN, the wireless wide area network. And this is for a huge geographical region. We're a lot of times talking national or even global communications with this one. It uses licensed frequencies, and one of the technologies that fit into this is satellite communications. Traditionally, this is for internet service providers, network providers, big companies that move lots of data. End users usually never connect in using this technology. We have several wireless technologies that we use in today's world. First, we have Bluetooth. Bluetooth is that traditional Bluetooth headphones, Bluetooth keyboard, uses Bluetooth to connect your smartphone into your vehicle, that personal area network. But we also have a couple variations of Bluetooth. We have the BLE, the Bluetooth Low Energy. Now this supports mesh topologies, and we can also scale this up to larger network devices. It's a pretty interesting and new and developing version of Bluetooth out there. The second one in Bluetooth family is Bluetooth Basic Rate Enhanced Rate. And what we're doing is this supports point-to-point technologies. And what we see, the primary use of this is it's optimized for audio streaming. And so we're seeing more and more headphones, more and more Bluetooth speakers using this technology because it is optimized for a better Bluetooth sound. Next wireless technology is our Ymax, or Worldwide Interoperability for Microwave Access. Now, this was supposed to be the next great thing. It was supposed to supplement broadband in areas where there was either not necessarily a cable or DSL provider, someplace where they did not have an infrastructure to get broadband to rural customers. Now, this technology works up to 30 miles, and we do see it actually being deployed quite a bit in rural sections, like in farm country, and where we have the population density is not as much. Then we have cellular broadband. This is using the cell phone network to deliver data. And we're getting new technologies based upon that. We're coming out with more and more. 5G is coming out, and it's really exciting to see how fast these technologies are going to go. That some of these are going to get so good, so stable, so fast that people are going to start eliminating their DSL, their cable broadband connections to their homes, and just use these cellular technologies. We also have satellite broadband, where you can use a satellite, you can communicate up to a satellite in space and get your internet that way. Now, satellite broadband is typically for very rural areas where there's no infrastructure, there's no supporting infrastructure that will provide high speed bandwidth for internet, but they can put a satellite there, and as long as there's electricity, they can get high speed internet. And of course, we have our Wi-Fi. That's what we're used to. That's what we connect up into in our homes and our offices. When you go out and get coffee, you use Wi-Fi to do that. And that's what we're going to spend the majority of our time talking about. I hope you're liking this episode on an introduction to wireless. If you have the time, please leave me a comment and let me know what you think about an introduction to wireless. Also, you can visit my website at KevTechify.com for all of my details and how to get these episodes in video and podcast form. As we talk about Wi-Fi and internet and wireless LANs, we need to look at the IEEE standards. These IEEE standards, they provide how these work. How do we use these radio waves to transfer data? Now, like we talked about earlier, there's two groupings of radio frequencies that traditionally Wi-Fi focuses around. It's around the 2.4 gigahertz bandwidth and the 5 gigahertz bandwidth. That's when I'm talking about gigahertz and the bandwidth, that's like tuning your radio to a radio station in a car. You tune to one radio station that's at a certain frequency, and if you want another radio station, you have to tune to different frequencies. And what we have here are these two radio frequencies. The Federal Communications Commission, the FCC, has delegated that the 2.4 and the 5 gigahertz bands, and so it's a range between them, but it's focused on 2.4 and 5 gigahertz. They are open standards. We can do kind of anything we want in these frequencies. And what that allows us to do is we can build our Wi-Fi standards to work into these areas. As we have developed these technologies, as technologies went along, we started getting faster and faster and newer technologies up there. We started out with the original 802.11 standard. What this was is in the 2.4 gigahertz, and this was up to 2 megabits per second. And this was pretty fast then. I mean, the ability to walk around, look at that. But as we know, we want more and more data faster and quicker. And so the next Wi-Fi standard basically we're looking at is the 802.11. That now changed up to the 5 gigahertz. And depending upon how you're looking at it, it goes up to 54 megabits per second. And so the speed that this grew was 27 times faster, but you also had to have a different frequency. It was on a different frequency. And because it was a different frequency, you had to have different equipment to transmit and receive on those frequencies. Then we roll out the 802.11b. That is, notice it's on the same frequencies as 802.11, but this gave us up to 11 megabits per second. And so when we went from 802.11, just the plain one, to 802.4, it was 5 times faster. Now, it gave us a longer range than 802.11, and it was able to penetrate buildings and walls and interference a lot better than the 802.11a. And so depending upon your uses and what you had, it would work. Then came out the 802.11g. And that was still in the 2.4 gigahertz. This goes up to 54 megabits per second. Still has the ability to penetrate buildings, but it is backwards compatible with 802.11b. And so if you had an investment in 802.11b, you could go into 802.11g without getting rid of all your existing 11b technologies. And so a lot of people adopted G. Then we came out with the 802.11n standard, and it covers both 2.4 gigahertz and 5 gigahertz. Now, data rates for N go anywhere from 150 all the way up to 600 megabytes per second. And that's quite quick. And the reason there's a range is how you implement it. There's some ability in there to choose the way you do your standards. And if you're using the 2.4 and the 5 gigahertz technologies. The big thing with N here is you had to have multiple antennas. So you had to have multiple antennas because they used multiple frequencies at the same time. The technologies prior to N only used one frequency in the 2.4 range or the 5 range. Now, 802.N used multiple frequencies, and so that way they were able to push more through because they were using multiple channels at the same time. Then we came out with 802.AC. Notice that's just in the 5 gigahertz. That gives us a range of 450 megabytes all the way up to 1.3 gigabytes per second. So we can get lots of data transfer. And the big thing here is it supports up to 8 antennas. Now, what does that mean? It means that it uses up to 8 frequencies at a time, and that's how we can get that much more through there. And finally, one of the newer ones we have here is the 802.11ax that uses both the 2.4 gigahertz and the 5 gigahertz, and it's also able to use the 1 gigahertz frequency and the 7 gigahertz. And so it's going to be interesting to see how this new technology works. It's billed as the high efficiency wireless. So high efficiency wireless is what we see. And they've optimized it to send data across these frequencies to get data as fast as possible. And as we look at a company, and a lot of times, if a company made an investment in a technology, they made an investment in the B or the G, or even the N technologies, because a lot of times you will see access points and wireless routers, they cover multiple standards, or they design them so they're backwards compatible. And sometimes when they design them that they're backwards compatible, they put the new technology in there, and then they also put a transmitter and receiver for the old technology in it, and that's how they get this backwards compatible. But we're getting faster and faster and faster to get more data for our wireless users. I mentioned this already, but we're talking about radio frequencies. These radio frequencies, it's like tuning in a radio. And we have a range of frequencies. This is typically called a spectrum. Up here is a little chart I have on the spectrum, and way on the left side we have radio frequencies going all the way up to, on the right side we have some gamma radiation. What we humans can see is this little slice in here. This is what we can see in here. These wireless devices, they work in different ranges depending upon the technologies, the 2.4 gigahertz, the 5 gigahertz. They get their range, and here in the United States, the FCC says, okay, you can use this radio frequencies for these technologies in their license. The 2.4 gigahertz is an open one, and that's where our 802.11 B, G, N, and AX technologies work. And so the FCC has set this up saying you can go ahead and use this. 5G is for our AN, AC, and AG. Once again, the FCC said, okay, you guys can do this. Now, they really didn't say you can use this. What they've done is the 2.4 gigahertz frequencies and the 5 gigahertz frequencies is part of the ISM bands. ISM stands for Industrial, Scientific, and Medical bands. And these particular frequencies here, the 2.4 gigahertz plus and minus a little bit, and the 5 gigahertz plus and minus a little bit, they're open, and industry can use them, science can use them, medical professionals can use them, anybody can use those frequencies. Now, because anybody can use them, we can do whatever we want, so we build our wireless technologies to operate in those frequencies. There are a couple organizations that help develop these wireless standards. First one is the ITU, the International Telecommunications Union. What they do is they regulate the allocation of radio spectrum and also satellite orbits. And so if you want to launch a satellite into space, you're going to have to contact the ITU to find out where you can put your satellite into orbit. And also, if you're going to put radio on them, you're going to have to figure out what radio frequencies you can use. And so you go to the ITU. IEEE, the Institute for Electrical and Electronic Engineers. What they do is specify how a radio frequency is modulated to carry information. How are we going to get information on that frequencies? It maintains the standards for local and metropolitan area networks, and it handles the 802 family of standards. And finally, we have the Wi-Fi Alliance. What this does is it promotes the growth and the acceptance of wireless LANs. They don't really have to do a lot of promotion nowadays, but what they do is make sure that they follow certain standards. They make sure that equipment is interoperable. And a lot of times the IEEE comes up with these standards, and depending upon how you interpret these standards, you can make your equipment work one way or another way. And sometimes different companies can come up with how they interpret those rules from IEEE, and their equipment doesn't work. And so what the Wi-Fi Alliance objective is whenever you see that Wi-Fi stamped on the device you're buying, it is meeting an interoperability standard developed by them, saying, if you see this Wi-Fi, it'll work with any other device that's stamped with the Wi-Fi. And so it's a bunch of vendors that get together and did this, but it also makes sure that they are making equipment that all works together. It was my pleasure to provide you with this wonderful episode on Introduction to Wireless. If you like this episode and you get value out of it, and depending upon what platform you're using, please click that like button, give a 5-star rating, leave a comment. This all helps me bring you more great content. Please take a minute to subscribe to my channel. All of my socials and contact information are on my website, KevTechify.com. There you can find out how to get all these episodes in video and podcast form. In the upper right is my playlist for my series on switching, routing, and wireless essentials. In the bottom right is one of my favorite videos that I linked just for you. Thank you so much for watching this episode of my series on switching, routing, and wireless essentials for the CCNA. Once again, I'm Kevin. This is KevTechify. I'll see you next time for another great adventure.